Hello friends, up to last lecture we solved 6 questions from exercise 4.7. So we see remaining questions from this exercise 4.1. So see question number 7. The question number 7. Find the combined equation of the pair of lines through the origin and making an equilateral triangle with the line y equals to 3. So for solving the question number 7, we draw diagram for given condition. Suppose here line y equals to 3, which is parallel to this x-axis. This line we denote by L, and we have to find those lines which make equilateral triangle with this line L. So we draw two lines passing through the origin. Suppose this line is L1 and second line. Both these lines must pass through the origin because we have to find the equation of lines passing through the origin. This line suppose intersect to this line L at point A, and this line L2 intersect line L at point B. So we also call this line L1 as OA and this line OB or line L2 as OB. Now both these lines OA and OB make equilateral triangle with this line y equals to 3. So this angle must be 60 degree. This angle must be 60 degree. If you observe from the diagram, this line OA is a transverse to this parallel line L and this OX axis. So these are the alternate angle. So this angle must be 60 degree. That means this line OA makes 60 degree inclination with positive x axis. So from that we can calculate the slope of OA. Therefore, slope of OA is equals to tan 60 degree, that is equals to root 3. Therefore, equation of OA is y is equals to m into x. This form used for line passing through the origin. We have to substitute value of m as root 3. Therefore, y is equals to root 3x. Therefore, root 3x minus y equals to 0 is the equation of line OA. Similarly, we have to find the equation of line OB. Now, if you observe, this angle is 60 and this angle is 60. That means total inclination of this line OB with x-axis, positive x-axis, is 120 degree. Therefore, slope of OB is equals to tan 120 degree. So this can be written as tan of 180 minus 60. So we have to apply the formula tan 180 minus theta, that is minus tan theta. So using that we get tan 60. Again tan 60 is root 3. So we get minus root 3. This is slope of second line. Therefore, equation of OB is, directly we write this as y is equals to slope of line OB is minus root 3 into x. Therefore, y, or we write this as root 3x plus y equals to 0. This is equation of line OB or line L2. Now we have to find its combined equation. Therefore, their combined equation is first equation is root 3x minus y, root 3x minus y. Second equation is root 3x plus y, root 3x plus y is equal to 0. There is no need to multiply these two brackets because these are in the form of a minus b, a plus b. So we use the formula a square minus b square. So we write here root 3x 8 square minus y square is equal to 0. So squaring each term, root 3 square is 3. Square of x is x square minus y square equals to 0. This is the required combined equation of line passing through the origin and making equilateral angles with line y equals to 3. Question number 8. If the slope of one of the lines given by ax square plus twice hxy plus by square equals to 0 is 4 times the other, show that 16h square equals to 25ab. Now question number 8 is same as question number 5 and 6. Now we have to find the conditions if one slope is 4 times the other slope. So the equation is ax square plus twice hxy plus by square equals to 0. So we write its auxiliary equation, that is as bm square plus twice hm plus a equals to 0. Now if one slope is m1, then other slope is m2 is equal to 4 times m1. Now we know that if m1 and m2 are the slopes, then we write m1 plus m2 as minus twice h by b, and m1 into m2 is equals to a by b. So from this we can write m1 plus m2. If we replace this m2 by 4 times m1, that is m1 plus 4 times m1 is equals to minus twice h by b. From this we write 5m1 is equals to minus twice h by b. Denote this as equation number 1. Now we find m1 into m2. So m1 into m2, here also we replace this m2 by 4 times m1. So 4 times m1 is equals to a by b. So after multiplying m1 into m1 square is equals to a by b. Now from this equation 1 we substitute the value of m1 also, or we can further simplify it. m1 is equals to minus 2 by 5 h by b. So we substitute the value of m1 in this second equation. So substitute the value of m1. Therefore, for m1 we replace by twice minus twice h upon 5b. H square is equal to a by b. Therefore, after multiplying or after squaring first, minus 2 square is 4, h square is h square, 5 square is 25, b square is b square is equal to a by b. Now cancel the terms here. 1b cancelled with b in b square. So after multiplying 4 into 4 we get 16 h square upon 25 b equals to a. Therefore we have to write this as 16 h square is equal to 25 ab. This is the required condition. That means there is no need to write its auxiliary equation in this problem. In question number 5th and 6th we write its auxiliary equation, but for showing this example we don't have need of writing its auxiliary equation. So skipping this, write the remaining terms. Question number 9. If one of the lines given by ax square plus twice hxy plus by square equals to 0 bisect an angle between the coordinate axes, then show that a plus b square equals to 4h square. To show the question number 9, given equation is ax square plus twice hxy plus by square equals to 0. We draw this figure. In this we are given that the line bisect the quadrants, so that line may be L1 or that line may be L2, because this line L1 divides quadrant L1 first and third. This line L2 divides the quadrant second and fourth. So if the line is L1, then the angle made by that line with positive x-axis is 45 degree. If that line is L2, then this line make angle 135 degree with positive x-axis, because these are 45, 45. This is 45, this is 45. So 45 plus this 90, we get 135. That means if the line is L1, then its slope we find by taking inclination theta equals to 45 degree. Therefore, if theta is equals to 45 degree, then slope m1 is equals to tan 45, that is equals to tan 45 is 1. Therefore, if theta is equals to 135 degree, then slope m2 is equals to tan 135 degree. So for this we write tan 180 minus 45 degree. So we have to apply the formula tan 180 minus theta, that is minus tan theta. So we write here minus tan 45, which is equals to minus 1. Therefore we get the slope as m equals to plus or minus 1. When m equals to plus or minus 1, so substituting this value as a root of auxiliary equation, so we write the auxiliary equation for this given equation. Therefore, auxiliary equation for ax square plus twice hxy plus by square equals to 0 is bm square plus twice hm plus a equals to 0. That we already see how to write the auxiliary equation in previous examples also. Therefore, substitute the value of m as plus or minus 1. Therefore, put m is equals to plus or minus 1. Therefore, b into value of m is plus or minus 1. So we write here plus or minus 1 its square plus twice h plus or minus 1 plus a equals to 0. Therefore, after squaring plus sign we get plus, after squaring minus sign we get minus. So from this we can write also b plus a is equals to this plus or minus we shift to right hand side. So we write plus or minus twice h. So we get here a plus b is equals to plus or minus twice h. So after squaring on both sides, therefore we get a square plus b square plus twice ab is equals to, or simply we can write its square only. Therefore a plus b bracket square is equals to, so after squaring we get 4h square. This is a required condition. This is a required condition. So in this way we solve all the examples from exercise 4.1.